Hey everyone, welcome back to Engineers Concept Zone. Today we're diving deep into one of the most important experiments in material testing, the tensile test. Ever wondered how engineers find out a material's strength, ductility, and toughness? Or what those famous terms like yield stress, ultimate tensile strength, and fracture point really mean? In this video, we'll go step by step through the tensile testing procedure, understand the stress-strain curve, and decode how a simple test tells us everything about a material's behavior under load. So grab your notes, because by the end of this video, you'll clearly understand why materials fail, and how that tiny curve on the graph reveals it all. Let's begin with the test setup and specimen dimensions as per ASTM standards. Tensile testing. Tensile test is mainly used to determine tensile properties such as yield strength, percentage of elongation, Young's modulus, fracture toughness, and resilience properties. The test will be carried out in Universal Testing Machine, UTM. The tensile testing is carried out by gripping the specimen between the opposite ends of Universal Testing Machine and subjected to gradual increase of tensile load till the specimen fractures. The standard size of the test specimen and its geometry as per ASTM standards. Parameter, dimension, diameter, 12.5 mm plus or minus 0.25 mm. Parallel length, 57 mm. Gauge length, 50.8 mm. Fillet radius, 3 mm. During the test, the tensile load as well as the elongation of previously noted gauge length in the specimen is measured with the use of load cell of the machine and extensometer respectively. Stress versus strain curve. The sample is fixed between the grips of UTM and the top plate is moved upwards with certain speed. Elongation and strain is produced in the sample as load is applied, but the sample will resist the strain with a downwards force F, which is measured by the load cell connected in the UTM. Load versus elongation curve or stress versus strain curve can be obtained as shown in figure. Failure behavior of sample. When the sample is loaded up to the point A, stress is directly proportional to the strain, known as proportional region OA. If the sample is loaded up to the point B, the sigma proportional to epsilon, but by removing the load the sample will gain its original shape, known as elastic region, OB. The corresponding stress at point B is known as yield stress, sigma y. If the sample is loaded beyond the point B, the displacement of atomic planes is slow. Produces plastic strain up to the point C, but it will bear the elongation load. The corresponding stress at the point C is known as ultimate tensile stress, sigma UTS, equal tensile strength of the material. If the sample is loaded beyond the point C, the displacement of atomic planes is fast, produces severe plastic strain, where severe increase in length and decrease in cross-sectional area of the sample takes place. Finally, the sample will fail at point D. Failure behavior of sample ductile fracture, dislocation mediated, extensive plastic deformation, necking, formation of small cavities, enlargement of cavities, formation of cup and cone. Typical fracture structure with dimples: A. Necking, B. Cavity formation, C. Cavity coalescence to form a crack, D. Crack propagation, E. Fracture. Please like, share, and subscribe.